This is an introduction to writing functions in C++. You should have already used functions, probably quite a few different functions in your code, such as the square root function. The square root function is located in the math.h library. And so when you call that function in your main program, you follow it with an opening and closing parentheses, and you put the parameter or argument that you're sending to the function. Then the function up here in the math.h library makes the calculation and it returns the result back. So this gets replaced with what the function returns. So just kind of like this. So here is your function in your main program, square root. You send the parameter or argument, both terms are used, to the square root function, which is in the math library. It takes that parameter, it makes its calculation, and then it returns the answer back. So this gets replaced with the number 5. Okay, so now we're going to start out writing functions. We're going to write some functions that are very, very simple, the type of functions that you wouldn't normally write. Okay, so just for example, let's start with one. I'll get rid of the math. I'm going to put the functions above main for now, and then we'll talk about that, why I'm doing that. And so we're going to start with a function. Let's just start with the simplest little function, and let's make a function that squares a number. So let's send it the parameter 5. So you normally wouldn't do this. You'd just go 5 times 5. But just for the purpose of writing a very simple function, and the function square, it will take this one parameter and then it's going to square the number and return the result back here. Okay, so now to write these, and by the way, if you tried to compile it just like this, it's going to say, it's going to give you an error and say the function error square was not defined. Okay, so we need to write that function. Okay, so now I'm going to put that function up here. And the function is going to be kind of similar in format to your main. Remember that main is the function that is the entry point to your program. And so a function starts with a variable type that it returns. And in this case, we're just going to work with an integer. So we're going to have it return an integer. And then the name of the function, we'll call it square. And then the parentheses. Okay, in this case, when we're writing the function, we need to declare a variable or variables to take on the parameters or arguments that's being sent to it. Because this 5 is going to be sent right up to whichever variable we declare. And so we'll make that an integer. I'll just use the variable n for number. And so now a very simple function like this, we can just do it in one return statement. So I can just say return, and then what do I want to return? Well, I want to return the parameter times a parameter, which the 5 is being stored into n, so we just return n times n, like that. So let's run the program, and it returns a 25. Okay, so a very, very simple function. Okay, so now let's do one cout. I'll just put these in cout statements real easy. Let's go for product. Again, this is too simple of a function. You wouldn't write it. You would just multiply two numbers together. But this one takes 2 parameters. And so we're going to do the product of, we'll send it 2 parameters, 3 and 8. So it's going to multiply those 2 numbers together and return the result right here. Okay, I'll put the function up here. So again, it will be an int, the return type, the variable type that it returns. And again, this needs to match, this variable type right here needs to match what you're returning right here. Just like here in main, the return type, the int return type needs to match this right here. Return a 0 because 0 is an int. Okay, so the name of this function is product. And now this one will take 2 parameters. So we need to declare 2 variables to store the 3 and the 8. So I'm just going to name those variables. How about A and B? A, and then you'll need to do a comma, and you can't do just B, you need to put the variable type for each parameter, just like that. Okay, so once again, when we call this function, the 3 will get sent to A and the 8 will get sent to B. And so again, this is a very simple one. We can just return A times B. Okay, compile and run it. And so 25 and it's the first one, and then 24 is the second one. Okay, now let's make our function slightly harder. Let's go for a function that returns the largest of two numbers. I'll just send it the same two numbers, same two parameters. So this is going to look at these two parameters and pick which one is the largest and return it. Okay, so I'll put that function right here. And we're still working with integers. Of course, we could do floats. You know, if these had decimal points in them, we could do float. And so this one is going to be called largest. And two parameters again, we'll call them A and B. Okay, so in this case, we can't just do a single return statement. We need to see which one is bigger. And to do that, we could say if A is greater than B. Okay, so if the first one's greater than the second one, then we're going to return the first one. And then we can do else return the second one. Okay, so let's watch it run. And so it returns an 8. And let's switch these to verify that it works. Let's make 8 the first parameter and 3 the second parameter. And now it still returns an 8. So it's selecting the biggest one of these two parameters. Okay, so now a little bit more on the return statement. When you do a return statement, you exit the function. Okay, so any code after a return statement is not executed. And for that matter, this could have been written just like this without the else. Okay, because if A is greater than B, you're going to return A and exit the function. Otherwise, the next line of code is just return B. Okay, and remember that any code you put below a function is non-reachable. It will not execute. Any code you put below a return statement like that. Okay, so so that takes care of that. Now let's pause for a second and talk about why we should use functions in the first place. Why put code in functions? Well, obviously these are very simple. Even though this largest, that could be a decent function to put in your code. One of the principles of programming is code reuse. Reuse as much code as you can. And you've already been doing that. When you do a square root function, you're reusing some code that someone else wrote and put into a math.h library and distributed along with the compiler. Okay, so let's say that you're going to program a video game, a 3D video game. Well, do you want to write that code from the beginning, or are you going to reuse some existing code, such as one of the game engines, like Unity or Unreal Engine? So you normally want to reuse as much code as you can. Then you can focus on writing the things that really matter. Okay, so and also functions can be good inside of your code. If you're going to reuse some code within your same within your main program, do it over and over again, then you can put it in a function. Okay, now let's do something let me go over a couple other things. One of the terms is side effects. Okay, when I call this function largest of 8 and 3, I just want it to return the answer to me. You normally wouldn't put output inside of a function like this. Okay, we would call that a side effect. if I'm calling the largest function, I just want it to return the answer to me. I don't want it to output stuff. And so again, this is something that you would call a side effect of the function. So you want to send a function something and then have it return something. So we normally wouldn't do that, a cout in a function like that. However, it could be sometimes you may want to put some of your code in functions to keep your main program simpler to read. So for example, maybe you're going to have an intro screen for your program. You know, a little introduction screen that prints a bunch of stuff. And so this will make your main program simpler to read, saying, oh, okay, let's first do the intro screen. Okay, in that case, I'm going to create a function that does a bunch of couts. And it's not going to return anything. I'm not couting this. It's just going to do stuff. It's going to do the couts for me. And so if you have a function that doesn't return anything, you'll put void for the return type. Intro screen. And I'm not sending any parameters. Again, this is just to keep this code out of the main program. And so then, you know, this is my intro screen, blah, blah, blah. Program, blah, 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 blah. You know, whatever. So you can put a big intro screen. Okay, so now that should run. Here's my intro screen, blah, 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 and then those other calculations. Now, let's talk about why I put my functions above main instead of below. Okay, if I'm going to take this this square function right here, and I'm going to now put it below main. Okay, and now when I compile it, I'm going to get an error. The error is square was not declared. Okay, and this is kind of similar to, you know, variables have to be declared before they can be used. Otherwise, the compiler doesn't know what that is. Same with functions. A function needs to be declared before you use it. And when you're compiling this code, it starts from the top down. And it's like, okay, we just declared the function named product, the function named largest. We just declared the function named intro screen. Now we're using the function intro screen. Now we're using the function square. Oops, we haven't declared the function square yet because it sits down here. Okay, so that's the issue. So to do this, and this is really considered the proper way to write functions in your main code here, is to put a function prototype up here. And the function prototype is pretty much just the first line of the function, like that, followed by a semicolon. So we'll call this function prototype. Declare the function for the compiler, then the order that the functions appear in the code don't matter anymore. And now we can compile it and run it just fine. Let's do these other functions. So I'm going to put these other functions down below main. Looks like I'm missing a closing brace there. Now I need to I need function prototypes for these other ones. Remember, it will be followed by a semicolon and then the largest. Create my function prototype for largest, and then intro screen. Semicolon. Okay, so now my function prototypes are up here, and then the program compiles and runs just fine. Okay, now this is fine, but really the function prototype doesn't even have to have the name of your parameter. The function prototype just needs to know you're sending an int variable. So you could actually just do it like this. It's up to you, but it's not hurting anything having the names of your variables in there. Okay, so now let's do another function that uses something other than integers. Let's go Let's go. How about number vowels? So this function, what we're going to do is we're going to send it a string, and it's going to return the number of vowels in this string right here. This would be a great use for a function if you needed to do that. I'll just go ahead and put it up here. No, we should go ahead and do the function prototypes, since that's what we've been doing right here. Okay, so number of vowels. Okay, so first thing you need to think about, what does it return? Well, this one still returns an integer, the number of vowels, and then the name of the function, number vowels. And then what we're sending it, though, is a string. I'll just name it S for sentence. So this function, and then, of course, let me put my prototype up here. Number of vowels. We're sending it a string. So this one, we need to step through every character. So we'll need a for loop. I'll declare a variable num is equal to 0. That will be my count. Or I'll just call it, since I'm calling it count, let's call it count. So then we need a for loop that steps through every character. And I is equal to 0. Well, I is less than s dot size. So that steps through every character in that string, I plus plus. And then, if that character is a vowel, we will increment count. So if s, I'll treat it as an array of characters, s index I is equal to an A, or it's equal to A, E, I, O, U. I'll leave out the Y and W's for now. If it's equal to A, E, I, or an O, or a U, then let's increment count. And then finally, we need the return statement. Wouldn't work without that. So after we're done stepping through every character, then let's return count back to the main program. Okay, so compile and run it. And so the number of vowels is 6. So that's an A, 2, 3, 4, 5, 6. Okay, so just a slightly different function right here. Okay, now let's go ahead and go for some more concepts. Let's go for this largest. Let's say that we want to find the largest of 3 numbers. Okay, so right now, if you try to compile it, it's not going to work because the compiler is going to say it can't find a function that matches 3 parameters because our largest function has 2 parameters. But the neat thing is that we can actually create another function of the same name that takes 3 parameters. Okay, and that is called overloading the function. Okay, so here is our largest that takes 2 parameters. Let's create another largest that takes 3 parameters. And so again, this one is called, this means overloading function. So you can have multiple functions of the same name as long as the parameters are different. And different parameters meaning the number of parameters or the variable type of parameters. You could have one that takes integers and another one that takes floats. So in this case, we could say if A is greater than B and A is greater than C, then return A. You could do else, or you could just do another F, because remember, if you do that return, you exit the function. So now it's either B or C. So if B is greater than C, then return B. Otherwise, if we're here, then it's C. Okay, so let's run this. And so that one should return the number 10. And so there it is, the number 10. Okay, now I'm going to go ahead and just simplify things to talk about something else. Let's just go back to this square function right here. So I'm just going to go one function called square. I'll just put it up here, just simplifying the code. Okay, so take care of that. And I'll just go ahead and put it up here. Okay, now let's talk about variable scope. So if here is the variable n, we're sending 5 to the variable n. Okay, so now if I try to see out the value of n right here, watch what happens when I compile it. I'm going to get an error, and it says n was not declared. Okay, so that is because variables are local. N is a local variable, because what that means is that when you declare a variable inside of a function, that variable only exists within that function. And that's a good thing, because we may want to reuse the variable n in a different function or in main here. So we don't want to have to worry about the names of the variables used. Okay, so once again, n only exists within this function right here. So when you return the value, that variable n goes away. And more specifically, when you declare these variables, they go onto the stack. They get pushed onto the stack, and then when you return, you exit the function, they get popped or removed from the stack. Okay, so that is your variable scope. Variables are local that are declared within a function. Okay, unless you do a global variable. And pretty much all textbooks will tell you avoid using global variables whenever possible. Okay, so don't start out with a global variable. There are some cases when a global variable makes sense. But a global variable, it could be seen within any function. So if I declared a global variable, well, I'll just make one called pi. Now this variable pi can be seen within any function. Global variable. So here I could see out the value of pi. Here I could return n times pi. Or let's just go n times pi. And so let's take a look at it. Okay, so the first thing it did is it printed out pi right here in main. And then it returned n times pi, but as an integer, so it cut off the decimal point. So I'm sending it 5, so 5 times 3 is 15, so that's what it's returning right here. So that is a global variable. And again, try not to use those. Okay, so n times n. Let me see, is there anything else I need to prototypes? Oh, okay, let's go ahead and talk about libraries. Okay, so now you may want to create your own library. So you could put functions into a library. I'm going to create a library just named stuff.h, and it's going to be in the same folder. So I could put that function there. I could put int largest, which took int a and int b. And then if a is greater than b, return A, otherwise return B. Okay, so I'm just putting those two functions in square and largest in a separate file called stuff. And this file is in the same folder as my source code, or if you're using an IDE where you create a project, you'll need to add that file to your project. Okay, so here, so I need to include that file. And if you include a file that's in the same folder as your source code, then instead of putting it in the less than and greater than sign, that means it's in the C++ compilers library, it will be in quotation marks, stuff.h. By the way, H stands for header file. Libraries don't have to be named .h. They could be a .cpp, but this is popular way to name them. So now I can do the square function, and I can also do the largest of 88 and 49. Okay, let's try running it, and there we go. So it squared 5, and then it gave me the largest of those two numbers. Okay, and so a pound include any or the pound sign is a pre-compiler directive. It means when you compile this program, it does the pound pre-compiler directives first. And what this literally does is it grabs the contents of this file and puts it right here. Oops, that I didn't get the whole entire content. Okay, Control C, grab the contents of that file and puts them right here. So that's literally what happens when you do the pound include. Puts that file contents right here, and then it compiles it. Okay, so anyway, I think that's all I was going to go on functions. Have a great day.